Okay, hello everybody. Welcome to join the 105th talk at Nice Community. Today, today we are honored to have Yuji as our speaker, who will talk about developing robust and trustworthy foundation models. Yuji is currently a postdoc at UIUC, advised by Professor Heng Ji and Professor Chen Xiangzhai. She received her PhD degree at Hong Kong Polytech, and her research is mainly focusing on interpretability, robustness, and trustworthiness in foundation models. She has published lots of papers, NLP conferences, and machine learning conferences, and she also organized lots of workshops and tutorials. And today, so without further ado, let's welcome Yuji to talk about the robust and trustworthy foundation models. And please feel free to get started when you're ready, Yuji.
Hi, Holland. Thanks for the introduction. Hi, everyone. I'm Yuji. I'm happy to have the opportunity to talk about my research today. My presentation title is Developing Robust and Trustworthy Foundation Models. My research focus is to interpret the model behavior, and make them more reliable by understanding and taking advantage of the knowledge mechanism of foundation models. So nowadays, intelligent models begin to master more and more knowledge. And actually, we wonder what is knowledge for large language models for the intelligent models. Actually, in the pre-LLM era, intelligent models often serve as a tool for extraction. It's like they can extract the massive information from the huge corpus, and get them well organized into the knowledge graph. And in the post-LLM era, actually the knowledge can serve as the knowledge basis, and the language model can be probed to output the target entity or relation similar to querying a knowledge graph. And in nowadays, we all know that many researchers are scaling the model to bigger sizes, and the models begin to be capable of doing more powerful things. So we wonder whether the knowledge in the model is also scaling. The model can master more and more knowledge. But we are curious about whether the blooming knowledge also indicates the stronger performance. So here we have an example showing that sometimes the intelligent models can show the mysterious behavior. It's like if we query the large language model with "put a cat in Schrödinger's box," after a while, the box is opened. What's the probability of the cat being alive? Then the model said that, okay, there is 50% probability that the cat is alive. However, if we query the model with a slightly different prompt as "put a dead cat in Schrödinger's box," after a while, the box is opened. What's the probability of the cat being alive? And the model will say that still there is 50% probability of the cat being alive. Actually, such kind of behavior is so mysterious because we already said that the cat is dead, but the model will still say that there is 50% probability of the cat being alive. So we wonder, what does the model know? Actually, we assume model have known the famous Schrödinger's box case, but it cannot give us correct reasoning output. And we are also curious about when and why the model will fail. And can we interpret such model behaviors and even make the model behaviors more predictable and reliable? So our main challenges for our research is interpretability, predictability, and reliability. My research vision is to open the black box by exploring more interpretable, predictable, and reliable knowledge mechanisms of intelligent models to make their behaviors more reliable and trustworthy. So for the interpretability, my solution is firstly to trace the model error back to the training source in its training distribution, and also I aim at revealing the more interpretable knowledge utilization process in inference time, and also to increase the predictability of model behavior. Our research is also the first to predict the hallucination rate based on the training data statistics. And also, we would like to, after we enhance the model reliability, we would like to make it more powerful in the downstream tasks. So we explore the knowledge-empowered foundation models for diverse, reliable real-world applications. So firstly, we talk about the interpretability. We trace the model behaviors back to its knowledge source. So the key question for the research is, why do the hallucinations occur? So for the previous research, researchers tend to assume that, okay, firstly, maybe the hallucination origin from the false training data, and also secondly, they assume that maybe the hallucination origin from out of corpus knowledge. However, we propose that even with all true training data, models can still hallucinate by combining the facts into counterfactual ones. Here we have some interesting cases. It's like if you query the model with "tell me some famous rock musicians from Korea," the model will output the very famous political figure Kim Jong-un instead of a real rock musician from Korea. So why does that happen? We also have the hypothesis, because from so many interesting cases, we can see that sometimes the more popular knowledge, the more dominant information in the query can overshadow and obscure the less popular knowledge in the query. So it's like in the Korean, there is a very famous entity, a very famous political figure, Kim Jong-un, that is highly associated with the entity Korean here. However, the rock musicians from Korea may be a relatively less popular knowledge compared to the political figure Kim Jong-un. So we assume that LM's dominant information can overshadow the less dominant information, termed as the knowledge overshadowing phenomenon. So here, after we propose the hypothesis, actually we are curious how we can explore this phenomenon further and see the important factors that will affect this phenomenon. So first, we need to give a formal definition of the knowledge overshadowing phenomenon. So from the two knowledge, from the case, we can see that we have two knowledge sets. One knowledge set, they are related to each other but different. So the first knowledge set is about the famous politician in North Korea, is Kim Jong-un. And another knowledge set is that a famous singer in North Korea is Kim Song-woo. So actually, the two different knowledge sets are related to each other but by some shared tokens here, termed as X share. It's the North Korean tokens here. And also they can be distinguished between each other by the XAI and XBJ. So here, like the XAI refers to the politician in the knowledge set A, and XBJ refer to the tokens singer from the in the knowledge set B. Then our hypothesis is that if the frequency of training samples in knowledge set A is much more popular than the training samples in knowledge set B, which means M is larger than N here, then we say that the distinguished token XBJ here as singer can be overshadowed by the more dominant information encoded by the XAI tokens here. That means when we query the model with X share XBJ, XBJ can be overshadowed and the model will output the hallucinated answer as YA instead of YB here. This is how we define the hallucination caused by knowledge overshadowing. And also we define the hallucination rate. This relative hallucination rate actually means to what extent the model is biased towards the more popular knowledge when the model tries to memorize the more popular knowledge correctly, but memorize the less popular knowledge incorrectly and bias it towards to the more popular knowledge. So after we define the knowledge overshadowing phenomenon, we are really curious about what factors contribute to the knowledge overshadowing. Can we know the mysterious behind the knowledge overshadowing phenomenon? So first, we explore this problem from the global perspective. So intuitively, that means that refers to the relative knowledge popularity between two different knowledge. It's like intuitively we can see that if a knowledge is more and more popular than another kind of knowledge, then the less popular knowledge can be more easily to get overshadowed by the more popular knowledge. So we define the relative knowledge popularity here from the global perspective. And also we explore the relative knowledge length from the local perspective. That means in a sentence, it's like a famous singer in North Korea is. So what in the original sentence is not long, but what if we increase the relative length of the North Korean here, and actually it can decrease the relative knowledge length of the singer here. And we are curious about whether the singer will be more easier to get overshadowed by the North Korean concept here if we decrease the relative knowledge length of the singer. Actually, it can also be intuitively understood. It's like if some important information in our sentence is shorter and shorter, then we can get more easily to ignore that. That is also similar to knowledge overshadowing phenomenon. And also, we are curious about how the model size will affect knowledge overshadowing phenomenon. Why we are curious about that is because for a long time, researchers tend to assume that as long as we continually scaling up the model size all the time, it tends to solve all the problems, right? So actually, we are curious about whether the hallucinations caused by knowledge overshadowing can be trivially solved by scaling up the model sizes. So actually, we conducted the rigorous and comprehensive control variable experiments to explore the effects of the different factors on the knowledge overshadowing phenomenon. So here is how we construct our synthetic datasets. The reason why we construct our synthetic datasets and pre-train the model from scratch on our synthetic dataset is that most of the training corpus are not open source, so actually we cannot analyze their distributions. And also, actually, the expression of the knowledge is vague sometimes. It's like one same knowledge can be expressed in many different ways. So it's hard to rigorously analyze the relative knowledge popularity and relative knowledge length for different knowledge in some existing large language models. So here is how we construct our control variable synthetic data sets. So it's like we have a more popular knowledge here as Happy New Year. That means the model should output year given happy and new. And we have the less popular knowledge set here as Happy Groundhog Day. And the Happy New Year appears more and more frequently than the Happy Groundhog Day in the training corpus. Then what happens when we test the model? We found that if we prompt the model with Happy Groundhog, actually the model will output a year instead of day. It's because the less popular knowledge encoded by the distinguished token Groundhog here is overshadowed by the more popular knowledge Happy New Year here. So we also after we constructed the synthetic data sets, we also tested the existing large language models on some small fine-tuning datasets in some different tasks to test whether our observations still stand for the existing large language model trained by other corpus. So we also constructed datasets of the event location query, the logical deduction query is like there are two events, event A and event B, which was earlier, A was before B, B was before C. And this is more popular knowledge here, and the less popular knowledge is which event A, event B, which was earlier, A was after B, B was after C. Then we query the model with this. Actually, the model will output event A because actually the more popular patterns of something before and output event A actually overshadows the logic here of something after and outputs event C. So this is very interesting, and we are curious about whether we can find some rules about this phenomenon. And interestingly, after we pre-train the LLMs from scratch on the synthetic dataset on the control variable setting, we found that the three important factors, the model size, relative knowledge length, relative knowledge popularity, they all follow a log linear law. That means whenever the three important factors increase in the logarithmic scale, the hallucination rate will always increase in the linear scale. This is really interesting because this actually means that we found the log linear law of hallucination, the scaling law of hallucination. So actually that means that the most important implication here is that can we predict the hallucination even if we don't do the model training or inference? As long as we have the access to the training distribution, we can actually predict the hallucination rate just by the statistical analysis of the training corpus. Actually, this also increases the predictability of model behaviors based on the knowledge mechanism. And also we want to verify the log linear law. So it's like we found the log linear law from the synthetic pre-training language model, and we then we use the fine-tuned LLMs published by other researchers on the fine-tuned on the natural language dataset and see whether this also the hallucination law can also fit these real world LLMs, and we can find that this fits really well, and the relative prediction error is low as 8%. So the most important implication is that actually we successfully predict hallucination before model training or inference by log linear law. We shift the paradigm of the hallucination detection from reactive detection to proactive prevention, proactive prediction. And here is a case study of the closed source SOTA LLMs. Why we do this is because after we test our pre-training LLMs, actually we are curious whether the very big, very powerful SOTA LLMs still suffer from the hallucinations caused by knowledge overshadowing. And we try the GPT-4 and the DeepSeek and the DeepSeek closed source model. We found that, and here is an interesting case. It's like if we say put a dead cat in Scotland's box, when we open the box, how much the possibility is the cat alive? Then the model will give a correct answer instead of hallucination. Why does this happen? Then we change the query. It's like we increase the context length of the Scotland's box here, blah, blah, blah. And actually it can decrease the relative knowledge length of the entity dead here. And then we can see that after we reduce the relative knowledge representation length of the word, the less popular knowledge dead here, the model continues to hallucinate. It says, okay, 50% of probability of the cat being alive. So this is also interesting. That means even if we do not have the access to the training distribution of the closed source model, we can kind of test it whether it obeys the log linear law in the relative knowledge length. And also on the DeepSeek and Quinn model, although they are very powerful and very big, we found that they still suffer from the knowledge overshadowing phenomenon. It's like if we kill the Quinn model, who is a very famous African researcher in machine learning area, it will answer Joshua Bengal by overshadowing the less popular entity African here. And after we test this on the closed source model, we wonder, so sometimes since most of the LLMs are closed source, we cannot access their training distributions. What we can do if we want to predict some hallucinations or detect some hallucinations or even eliminate them. So we propose the method based on inspired by the knowledge overshadowing phenomena. So imagine that now we want to predict and eliminate the hallucination in inference time. So imagine that we have a query here, like who is a famous African researcher, and how can we judge whether there is some tokens or knowledge overshadowed here? So it's like if the token African XB is not overshadowed, actually the model will output YB given XB. And the ground truth answer is Francis and Elote. And if the XB is overshadowed, actually the model will output YA given XXB. The answer is Joshua Bingo. So how can we identify that? Actually, we propose that we can sequentially mask the potentially overshadowed token in the original sentence. If the masked tokens is overshadowed here, the output distribution will remain similar to the unmasked version, to the original version. So that means if we mask some tokens in the prompt and the model will continue to output something very similar to its original output, that means the masked tokens doesn't matter to the model. That means the hallucination phenomena, the overshadowing phenomena occur. So now how we can identify which tokens encode the overshadow tokens, we utilize the point-wise mutual information here. And if the relative point-wise mutual information is less than 0, this indicates here the output tokens YI is more associated with the masked version X prime, which has been removed the overshadowed knowledge representing the dominance bias, the more popular knowledge. And actually, the sum of the negative value of IPMI actually quantifies to what extent is XB overshadowed by X prime, and the output is biased towards the dominance knowledge X prime. Here we still have a question. So after we can identify that there are some tokens overshadowed by the more popular knowledge, how we can distinguish whether the tokens encode a benign overshadowing or a malignant one? What do we say what do we mean by the difference here? So actually imagine that if you say 1 plus 1 equals 2 and 1 plus 1 indeed equals 2. So actually the word indeed here is a benignly overshadowed token. It's because it doesn't matter if we delete or we keep the indeed word here. So actually we do not want to classify such kind of overshadow tokens into hallucinations because they are benign overshadowing. So here we also propose the escaping rewarding mechanism to quantify whether the knowledge is a benignly overshadowed one or a bad one. So actually the escaping rewarding mechanism is to quantify the knowledge escaping from the overshadowing effect. That means if an output token is associated with the original version, but not associated with the masked version. That means this token is unrelated to the dominant bias, the more popular knowledge. Then we will give reward signal to such tokens. And here is how we balance the indicator. We just do the summary between the IPMI and the escaping rewarding mechanism value. And if the indicator is positive, the token is overshadowed with overshadowed knowledge, then it will incur a hallucination. But if the indicator is less than 0, the token is benignly generalized. We should not classify it into the hallucination. Then after we identify the overshadowed tokens, we will do the contrastive decoding to eliminate the dominant bias brought by the more popular knowledge. We just do the deduction between the two output distribution, output by the masked version and the original version, and then predict the optimal output for continued generation. By the deduction, actually we deduct the dominant bias brought by the more popular knowledge output distributions. Now here is our empirical results. We can find that our method significantly outperforms the previous SOTA method. And we also do the analysis on the synthetic data sets. It's like we can see that when we increase the relative knowledge popularity and the relative knowledge length, that means the model, the less popular knowledge is more overshadowed here. We can find that the performance of our method just dropped. This is because the more popular is overgeneralized, the harder it becomes to extract the valuable information from the suppressed knowledge representations. So here I also would like to quickly explain the overgeneralization here. So actually in our hypothesis, we assume that hallucination is actually the overgeneralization of the more popular knowledge. And to give some theoretical insights, we also include some theoretical proof in our paper. So it's like we derive the generalization error bound of the more popular and the less popular knowledge sets. We found that as the relative knowledge popularity and relative knowledge length increase, actually the generalization error bound continues to increase. That means that echoes our empirical results on the log linear law. So after we conducted the knowledge overshadowing exploration, we want to go beyond the knowledge tracing to knowledge utilization for challenging tasks. This is because although we can trace some errors, although we can trace the hallucinations into the training distribution, into the origins of the model behavior, actually it cannot. When it goes to some challenging scenarios like some complex reasonings, some complex reasoning tasks, sometimes we cannot trace clearly all the errors. We cannot explain it, and the model sometimes also exhibits the mysterious behaviors. So we would like to, so the next step of our research is to increase the interpretability and reliability of knowledge utilization in the inference time. And actually in the real world scenarios, the intelligent model can be applied in complex and challenging domains where the reliability is very significant. It's like especially in the scientific domain and in the medical domain, some error information generated by the model can have very severe outcome. So actually we are curious about how the model will search and utilize knowledge in inference time for the complex tasks. Here is an example. So this is the scientific table claim verification task. Actually, in the scientific papers or some scientific analysis report, the table is a very important information container to express the important scientific information. So actually, some people may take advantage of the professionalism and the complexity of the table to manipulate some claim and try to do some rumor propagations and to incur the severe outcome. So actually, this task we aim at verifying whether a claim is supported by a scientific table or not in this project in the challenging scenarios. And we can see that if we query the ChatGPT model to do the intuitive reasoning, which means we do not let it to do the chain sort reasoning, to do the long sort reasoning, we just want it to give us the answer by its intuition directly, then it will give the incorrect answer, said as the claim is supported by the table, give a wrong calculation result here. And then we use which prompts the model to use the chain of thought reasoning to reason in a long chain about whether the claim is supported by the information in this table. We can find that it still fails to give the correct mathematically calculated answer here, and so the verification is wrong here. So we are curious about, can we make the reasoning process more interpretable and reliable? Actually, we do not know what happens when the model tries to search and utilize the different knowledge to support its reasoning process, right? So here we propose the atomic reasoning. That's our motivation actually comes from our observation from the task. We found that sometimes the model can fail on some very simple tasks. So we propose that instead of training the models on the complex data, on the challenging data, on the very long data, can we just focus on training the model on a small set of skills? The small set of atomic skills is like we just train the model to do the planning well, to do the structural analysis well, to do the numerical calculation well, and by this process, actually we increase the interpretability and the knowledge utilization mechanism in the inference time. And after we train the model on the small set of atomic skills on these kind of complex reasoning tasks, we can find that the performance is greatly enhanced. Actually, our key principle is here that we want the model to learn smarter, not harder. So actually training the model on a finite set, on a small set of atomic skills, actually lower the cognition load of the model. That's the reason why it can enhance the model performance instead of relying on large amount of data training or complex data training. And our experiments show that with only 350 training samples, our small model trained by atomic reasoning outperforms the state-of-the-art GPT-4o chain of thought reasoning performance. We can find that the performance is very significant on the small model, and this even outperforms the SOTA ChatGPT chain of thought reasoning. And also, our results show that models trained by atomic reasoning scale more efficiently than the chain of thought reasoning in training and inference time. And also, we do the error analysis showing that atomic reasoning enables more reliable knowledge reasoning. It reduces the snowball errors propagated and reduce the context conflicting errors because it can better utilize the different knowledge reasoning skills. And also it reduces the coarse-grained errors because the model is more good at using the different knowledge granularity to do the reasoning. And after we complete the atomic reasoning exploration, actually, we are also curious about the more challenging real-world applications, the more diverse real-world applications. We can find so intelligent models interact with the environmental knowledge, with their internal knowledge, can empower the real-world applications. This is our next exploration. So we explore it in the scientific domain, the public health, and the interactive games domain. So in this work actually focuses on the drug shortage simulation for the to benefit the public health. So it's like when the severe health or severe disease crisis happens, like the COVID, sometimes some drug supplies can be really limited and under a mess because the government, the suppliers, and the buyers that don't know each other, then don't have the prediction. They don't have a prediction and foresight for the upcoming crises. So this can actually incur severe outcomes, especially under the information asymmetry. So actually, our method is to transform the original system from the information asymmetry scenarios to the information transparency scenarios. So then in this work, actually we utilize the multi-agents collaboration to do the information games under the information asymmetry. Is like they guess each other and they make the decisions under the great uncertainty to increase the information transparency of the whole system. And also, the knowledge mechanism is also associated with creative model intelligence. That actually means after the model masters some knowledge, that means the model can also utilize the knowledge very flexibly and intelligently. So actually in this work, we explore whether the large language model, the intelligent model, can have the creative intelligence to solve some real world task creatively. It's like whether the model can think of the diverse and creative ways of utilizing a same tool in an escape room scenario. And we found that actually the model, although we assume that large language models are very powerful at solving the real world tasks, we can find that they are still underperform the average human performance a lot, showing that the model cannot take advantage of its creative intelligence, and also it cannot utilize its master knowledge flexibly and intelligently to solve the real world tasks. So here is a whole picture of my research. My research principle is to transform the black box intelligent models into more reliable, interpretable, and predictable LLMs. And to do this, actually, I firstly try to trace the error and interpret the errors back to its training corpus. This is the knowledge overshadowing project. And also I do the fourth step. This is to increase the interpretability and reliability of the model reasoning process in the inference time in this atomic reasoning paper. And also when we identify that some black box LLMs have some incorrect information or knowledge inside, can we do the knowledge updating? Then another of my research is focused on learning new information, is to do the temporal adaptation. It's like how to update the model's outdated information to the up-to-date one. In this work, actually, we use the mutual information to do the information disentanglement between the past and the future knowledge, and we also model the time variant and time invariant feature of the in a timeline, and let the model to sequentially adapt to the time variant features, which is the future feature, to predict the feature. In this paper, actually we utilize only 3% of the training data of the previous paper unsupervisedly and achieve the SOTA performance than the previous benchmarks. And after we do the learn, we also curious about how we can do the unlearning. So it's like now we have maybe after we update some model, the model can include some private information or harmful information that we would like to eliminate. We would like to delete from the model. Then we propose and some researchers work on this by do the gradient or seeding on the forget data. However, this can harm the model's performance on its originally retained knowledge. So this kind of trade-off is very severe, because if the model only does the unlearning and can also harm the original useful information inside the model, this can make the model collapse. So we propose our geometric disentanglement unlearning to solve this problem, to solve the trade-off. Means actually we want to propose a theoretically sound, theoretically sound or theoretically motivated method here. And most of the previous work try to tackle the trade-off between the forget knowledge and the retain knowledge that use the heuristic methods. That means sometimes they assume that the similarity between the gradients or the similarity between the knowledge embedding actually measures the knowledge entanglement between two knowledge. However, we use a theoretically motivated method here. So it's like we want to analyze when the retain gradients, the retain knowledge is locally invariant when we update the forget gradients. So, and then we found the crisp equivalence here. That means the retain gradients, the retain knowledge is not harmed by the harmed by the forget knowledge. Is not is locally invariant only if and only if the gradient of the retain knowledge is orthogonal to the gradient of the forget knowledge. So that actually motivates us to do the orthogonal decomposition of the forget gradient. Then we project then we only retain the orthogonal projection of the forget gradients that is orthogonal to the retain knowledge, and our method exhibits the good performance for solve the trade-off and can be plug and planned to existing learning methods. And also after we work on the reliability and the interpretability, predictability of the black box intelligent models, we apply it in the more diverse applications like discussed before. So this is all of our research, and this is all my presentation today. Thank you so much for listening. This is time for Q&A now.
Thank you, Yuji, for the nice talk. It's really informative. Yeah, maybe let's see if we have some questions. I guess there are some questions from the WeChat online. Maybe I will ask them questions first, and then I will also ask some of my questions so I can discuss more. So the question is about, could you please explain more about using the PMI to detect the knowledge overshadowing? I think this is about your first part. Use a pairwise reward modeling, right, to do the knowledge overshadowing. So the question is mainly about, is there any assumption on this and why this is useful? Like why it works. Could you please explain more on this?
Yeah, sure. Thanks for the question. So actually the mutual information here is to quantify the association between the is to quantify how the output token is associated to the more popular knowledge and the less popular knowledge. And the mutual information definition is showing here. So it's like if the value is less than 0, that means the probability of yi given x is less than the probability of yi given x prime. So actually this means after we mask some tokens here, the output token probability increase. That means the output token is more associated with the masked version. And the masked version, like the famous researchers in machine learning area instead of famous researcher in famous African research, actually indicates the more popular knowledge here. So here is why this negative value of mutual information, point-wise mutual information can quantify that the output token is more associated with the more dominant information here. So did I answer your question?
Yeah, I think so. Actually, this question is not from mine, it's from the audience online. So I hope it also clarifies their concern.
Yeah.
Cool. So I really like your first work because I think it also talks about some scaling laws, right? So basically, we don't need to really run the model. We can, before we running the model, we can have some prediction. So actually, since we are talking about this first work, I also have some question about this scaling laws. So the first thing is, I'm not sure, maybe I missed this, some part. I'm not sure if you expect any saturation or threshold Like for instance, after some threshold, if the PLS they are keep growing, this kind of phenomenon will change. Did you have some insights on this, or you think it just can generalize very well?
Do you mean like if we keep increasing the relative knowledge popularity?
Exactly. For instance, like the SPL, like if you
Yeah.
keep increasing them, do you think there will be a threshold? Like suddenly, it will not have the similar trend.
Actually, I think there is indeed a threshold. It's because the
Mhm.
hallucination rate will increase to like 1%. That
And is
means,
there, yeah, mhm.
yeah,
Yeah,
sorry.
please go ahead.
Yeah,
No,
that
no, no,
means
please
the
go
less
ahead.
popular knowledge here is entirely overshadowed here. The model
Mhm.
just entirely compress the information encoded by the less popular knowledge here. It's like whenever we ask, okay, tell me some African researcher, the model will output the will always output the non-African researcher. That means the information here is totally crushed and totally compressed. So there is
Yes.
indeed a threshold here is 100%. And thanks for your question. This is a very important question actually.
And yeah, thanks for the answer. And also, do you think did you do experiment like if you test on models under RLHF or instruction tuning, um, will this schedule still apply on those models?
Oh, thanks for the question. I haven't do the research like on the iOS under the iOS HF training. I currently only train the model by the supervised fine tuning, and I feel this could be interesting because sometimes some experiments show that the previous experiments show that the
Mhm.
IOHF can make the model better aligned with the training distribution. So actually, I'm not sure whether this will make the overgeneralization phenomenon more severe or less severe. This is an open question, I think.
Yeah,
Very
thank
interesting
yes,
question.
exactly. It's your answer makes sense. Yeah, makes sense to me. And also, I think you also proposed a token level decoding method, right? The CODA.
Yeah,
I just have one question, maybe still open question. I think um, some hallucination or some fact, actually, they are not merely on token level, right? So
yeah,
probably they are on face level, like several tokens. So is there any intuition like why this also works on those scenario? Like, I mean, we only focus on token level, then we can also solve the issue on face level.
yeah.
Is there any better intuition behind this?
Yeah, thanks for the question. This is a very important question. So actually previously we also consider this factor, and it's like currently it's like the basic solution here is to mask the token one by one. So this is a token level detection. And also we try the
Mhm.
different entity extraction. It's like we can also mask like the African researcher. We can also mask the famous African researcher like this. We can have different entity selection strategies here. And I'm not sure whether this can answer your question, because sometimes I also agree that sometimes the knowledge association can be more abstract, and maybe they
Mhm.
cannot be represented by some like even in some paragraphs. And I feel
Exactly.
this is an important direction to explore in the future. Thank you.
Exactly. Oh. And also, since we're also talking about this, I think in this first work, you only consider about popular versus not popular knowledge, right? So basically,
Yeah.
it's a binary to me. So this is definitely an open question. I just wonder what will happen if you consider multi-class knowledge overshadowing. So for instance, you have not only popular versus unpopular, but let's say there are three different saying about the same topic, but they talk about different, but their answer is different, let's say, and they are about the same popularity level. So how are we going to handle this?
Yeah,
But
thank
I
you. The
mean, this is
question is
definitely
very
a very open question. Yeah.
yeah, the question is very insightful. And actually I also consider about that. So it's like I also want to point out an important point here. So it's like here we always say this is relative knowledge popularity, not the knowledge popularity. So
Mhm.
the relative here actually means this is a dynamic balance, and some word can be popular in some context, and the very popular word can become the unpopular word or less popular word in a different context. So I think this is also related to your question. So it's like you are asking about when the the relative imbalance phenomenon become more complex or become the compound overshadowing, which one will take the dominance? Then here currently in our experiments on the CODA strategy, we found that most of the time the most dominant overshadowing pair can dominate the whole sentence. So it's like let me refer to this case. It's like who is a famous research African, even if the sentence is longer. So actually, since the imbalance between the African and the researcher is more severe than other knowledge peers, so actually the model will be biased towards the African researcher related hallucination, not other hallucinations. And this can be also detected by the constructive decoding strategy. But I also feel that to increase the interpretability, even if the final output will only show one hallucination, it is also very meaningful to interpret all the overshadowing patterns before the inference, before the output.
Yeah, fully makes sense.
Yeah, thank you.
That's a very interesting point. Yeah.
Yeah.
And also, I think CODA is, although CODA is proposed for addressing hallucination, I think it can also be used to solve some other problems, right? So, for instance, if you have some, let's say, some domain knowledge, so probably it's not very popular. It's some very rare knowledge, or the knowledge is updated.
Yeah.
It's very new. So you can also use the CODA to make sure the model can answer the question correctly by using the how should I say, the niche knowledge and also the very updated new knowledge, right?
Yeah.
So I think maybe this can be also some future interesting direction.
Yeah, this is very interesting. I also agree.
Cool.
Especially in the underrepresented domain, this can be more
Exactly.
useful.
Exactly.
Yeah, thank you.
Cool. And also for the second work, I also think it's super interesting. I have a question is about if my understanding is correct, you assume the skill, basically the atomic scales, you follow a linear chain pipeline, right? So basically, there's no too many complex topology. For instance, we first do planning, and then we do the step 2, and then
Yeah.
basically step 3. So basically, it's a one direction linear chain.
Yeah, it's
So
a
I
more
just
classic
wonder,
way.
yeah,
Sorry, please continue.
I just wonder, like in real world scenarios, for instance, like in scientific discovery, probably the pipeline will be more complex, right? So, for instance, sometimes you will have some hypothetical exploration, and then it doesn't work. Then you go back one step, or we will do some in parallel exploration. So, I just wonder if this idea you mentioned in your second work can be extended to some more complex topology for using this kind of atomic scales. For instance, maybe you can frame it as a directed acyclic graph. So, I mean, it can have some more complex structure. Maybe it
Yeah.
can solve the more complex tasks. I don't know, but it's
Yeah,
just
I
some
totally agree.
question.
Actually,
Yeah.
thanks for your insights. I really agree. And this is actually highly related to our motivation when we propose this work. So it's like
Mhm.
so in the so actually, especially in the more complex and more challenging scenarios, the problems of the chain sort will be more severe. So it's like the model cannot control which kind of granularity the model should use to apply the different knowledge. It's like sometimes they skip some important steps, and the skipping of the important step can incur the huge hallucination, and sometimes they are too detailed. This is all the disadvantages of the chain sort reasoning, and the reason why we propose the atomic reasoning is that we not only want to reduce the cognitive load of the model during the training to let it learn more efficiently. We also want to present a more organized way to do the reasoning. It's like we design a skill chaining schema here to better define the conditioning, the probability conditioning between different skills. It's like sometimes you call some skills just right after some specific skills, and such kind of organized structure can actually help with the very challenging and very complex reasoning tasks. I'm not sure whether this answers your question.
Yeah, I think so. But I mean, we definitely can talk this more, but maybe we can hold this after this online talk. I
Yeah,
think this is also very interesting topic maybe to discuss in the future.
yeah, I also agree. Thank you.
And also, I just wonder a very random question, like, um, is it always good to predefine these atomic skills? Like, I mean, uh, maybe could you please clarify again what are exactly those atomic skills you define? So, for instance, like reasoning, planning, right? So basically,
Yeah, so
it's this kind
currently
of
I
thing.
can give some examples. It's like to
Uh-huh.
do the mathematical calculation or to
Okay.
identify the correct row and the correct columns for the specific value. So it's and also use some domain knowledge. So it's like if we you can see that
Yeah.
in this scientific table, actually we cannot understand what are the concept here. And actually, we expect the model to first recognize the domain knowledge should be used here and explain the domain knowledge. And after it use the domain knowledge to recognize the important value to be extracted from the table, it conducts the next step to do the location, to do the value location. So it's like it first counts the rows, then counts the columns, then identify the value, and after it extract all the value from the tables, it use the next skill to do the calculation, and after it do the calculation, it do the causal analysis based on the value and the domain knowledge, such kind of skills. And I also feel that there might be a limitation here. So it's like after we use we use the model in the different domain, actually we need to define a
Exactly.
new set of atomic
That's
skills
true.
here.
Mhm.
Yeah.
Exactly. That's also what I want to ask. Like, is it possible to learn these skills? Because maybe for different domain, as you said, people require different skills, but maybe this is more challenging.
Yeah. I feel to get the skill definition process more automatic is also important for the atomic reasoning.
Yeah. Interesting. I
Thank you.
feel, yeah, yeah. Maybe we can also discuss this later in the future. I think there
Yeah,
are
yeah.
definitely lots of space to do.
Yeah. Thank you for
That's
your
super
question.
interesting. And also, I think in the end, you also talk about your future work and also planning later steps very well. I think it's really very insightful. I also have some random question to ask, because I know you are also you previously did research on interpretability and also hallucination, right? So I think recently, AI creativity is also a very interesting topic, and
Yeah.
I personally also very interested in this topic. I just wonder, from your perspective, because you previously are doing hallucination, so sometimes if we consider about creativity, right? So maybe some stuff, some new knowledge or some new claim, they doesn't align with the previous knowledge, but actually sometimes they may be true, and they maybe some people may call them as I mean, if we push it a bit further, if the larger model, let's say, can create some new knowledge or new skills, maybe we can call that creativity. So I just wonder, how do you balance this kind of things, or how do you treat this kind of thing? Like, how do you view the AI creativity, and how do you think those methods from the hallucination can be used here? Yeah, a very open question. Yeah.
Yeah. Thanks for the question. I also feel that the question is very insightful and very interesting. And also, I'm curious. I'm also curious about this direction. So, talking about creativity, how can we balance between hallucination and creativity? It's like sometimes we humans also do the hallucination, but some hallucination can uh actually inversely help us sometimes. So it's like we dream, and sometimes we dream some hilarious things. But
That's
such
true.
kind of
Mhm.
seemingly unreasonable things actually can solve some important real world tasks actually. And I feel that create to balance between them. First, we need a principle to define what is the creativity. So and also it also depends on different people's taste and different domain knowledge. So it's like in one domain, maybe doing something in a different way can be very novel and creative, can solve some tasks. But in another domain, maybe such kind of action is very common and not so creative. And actually, I think we need to define the creativity differently by the different principles in different domains. This may be the first step.
Actually, I would agree. I think also the creativity, maybe we should define it from some interdisciplinary view, right? And also we should constrain the scenario and situation when we
Yeah,
talk
I
about that.
agree.
Yeah.
Yeah.
But yeah, I think that's super interesting point.
Yeah.
Um, yeah, I really enjoy your talk, and I don't have more questions. Let me just check the other platforms to see if any audience have any questions.
Yeah. Thank you for your coordination. And I also learn a lot from your questions. it make me reflect
Yeah,
back to
thanks.
my complexity project. And I think maybe it's the time to do the next step.
Yeah, thanks. Thanks for your nice words. Okay, I guess from my side, I don't see any other questions from the other online platforms. I think the time is also good. So thanks, Yuji, once again for your nice talk. And also thanks everybody for coming. If you have any other questions, you can also email Yuji or email myself and also leave your questions. So our other hosts maybe will answer your questions later. Thank you so much.
Thank you so much.